Welcome to Closing the Loop, a podcast presented by Lakeside Process Controls, where we hope to connect you with experts, end users, and suppliers in the industrial automation industry. My name is Justin Koscak, Business Unit Lead for Measurement Solutions and host of the show. Each episode will feature different guests from either Lakeside, Emerson Automation Solutions, or other industry leaders. We hope that through these conversations, we can close the loop between your current knowledge and the latest advancements in industry. Our goal is to educate, provide you with ideas for improving your process efficiency and safety throughout your plant. And with that, I'd like to introduce you to today's guest, who's joining us from Emerson's Automation Solutions team. He's a product manager for North American process level, none other than Josh Friesz. Josh, welcome to the show.
Oh, thank you so much for having me. That's quite the introduction.
I was working on it all night for you. It was very specific, too.
I can tell, and you really delivered on it.
Thank you, Josh.
Yeah.
Well, welcome.
Thank you.
Is this your first podcast?
This is my first podcast.
Whoa.
Yeah. So
it's all downhill from here.
I hope so.
This is basically Joe Rogan, and then Closing the Loop is like a close second.
Oh, good.
In the space.
Perfect. Right. I will commend you on your podcast title. I was trying to explain this to my wife the other day on what it meant, and I don't think she fully appreciated it, but I love it.
Okay, I appreciate because I got a hard time for marketing about it because there's a lot of other Closing the Loop podcasts, and they're not industrial automation. They're like Bitcoin. So I guess it kind of applies to crypto, but it's way better for industrial automation. Like that's what we do all day.
Sure.
Yeah.
Yeah. It makes sense.
That makes me feel good.
Yeah.
So thanks for coming down to Toronto.
Coming down. That's right.
Coming down. We got to make sure that's correct. Every time we bring someone from Minnesota, they always think that we're further north than them in Toronto, but we're basically the Caribbean.
Yeah, it is. It's really crazy when I think about that coming here from Minneapolis, that it's a little further south, a couple degrees latitude south.
Yeah. Unfortunately, you did bring snow.
I did, which is crazy because we don't even have any snow in Minneapolis right now. So
it was just for today.
I just sent it down here to you guys.
It was just following you where you went.
Right.
So Josh, for people who don't know you, maybe could you give a little bit of background? Maybe, depends on how far you want to go back to your North Dakota days.
Oh, gosh.
We can go way back.
Right. All right. So, goodness, I am originally from North Dakota. I live in Minnesota now, but I did my schooling in North Dakota. I have an electrical engineering degree.
Oh, you're really smart.
Oh, gosh, right. You're chemical.
Yeah, which is down here.
Oh, no, I would put chemical up there.
I just like to tell people that.
Yeah. So anyways, I trained in electrical engineering. I worked as a hardware design engineer at a startup company in Fargo, North Dakota, right out of college for a couple of years. And then I joined Emerson in 2012. I just had my 12-year anniversary last week, which is pretty exciting. I started in our quality organization doing hazardous location approvals. So any flame-proof, intrinsically safe style approvals for pressure products. That's what I started doing. And then I kind of moved throughout the company, and I was a pressure product manager globally, launching new products. I spent some time in the hygienic space for food and beverage and life sciences. I've managed DP level products, and now I'm in this process level world. So,
and loving every minute of it.
I love every minute of it. It's been a really, really great learning experience, learning our level portfolio. It's been 2 years now, so I feel pretty comfortable in the space, but I'm learning new things every day too.
Well, that's the thing. So formerly as a level specialist for Lakeside, there's not a day where you didn't learn something new, right? Because the technology, you think you understand it, and then the next day, like, your mind is blown because you're like, no, this actually is magic what we sell. This is not science anymore. This is on the cusp of magic.
Absolutely, right. And in my electrical engineering training, we're like talking radio waves moving through space and all that stuff. So it is kind of a fun throwback to some of my training back in college. But yeah, it's a little more integrated than a pressure transmitter, you know, where you install it and you zero it and hopefully you're good to go. Level sensors, level transmitters are getting a lot easier, so things are getting much better for installation and startup. But yeah, they do, on tough applications, they require a little bit more hands-on.
Yeah, well, that's what I always say to some of the new people who join Lakeside. As I said, level is probably going to be your most challenging one, not because it's necessarily the most difficult. Like, there's some really easy applications out there.
Yeah,
it's just because you can't size anything. It's just like I know what's going to fit in the process connection, and that's it. I know it's within spec, but will it work is a whole other question.
Right, absolutely. Yeah, and it's a little little black magic sometimes, right? When you're making a microwave technology measurement, and it's a little less tangible than a pressure temperature sensor. Mm-hmm. So yeah, it gets a little goofy. People feel a little uneasy with it sometimes, but it works.
Hey, and it works really well.
Yes, it does.
And it's the 51st year now?
Yes.
For Emerson Process Level?
Yeah, we just celebrated, Emerson. So yeah, we just celebrated 50 years of innovation in the radar level space, which is quite a feat. Mm-hmm. And we have some really cool literature out on the internet where we talked about kind of the evolution the last 50 years of design in radar level. And, Emerson/𝗧𝗜𝗠𝗘 being the inventors of radar level in that technology space, and kind of where they've come from and where we are today.
Yeah, we previously had on Rich Ireland on the show.
Yeah.
And so Rich was talking to us a bit about from the tank gauging side of things, not
Sure.
just the process level measurement. And so, for those of you who have listened to that one, you probably know a little bit about the evolution, but I'm sure some of you listening might not have. So maybe you can walk through a little bit of the evolution of the technology. Because what's interesting was I was cleaning out one of our offices maybe a few months back, and I found a VHS tape that talked about FMCW radars versus pulsed radars. And
Sure.
I thought that was pretty crazy because, that thing was probably from the 90s. And now here we are talking about it again in 2024.
Right. Well, FMCW has a lot of staying power because it's been one of the cool recent, and by recent, it's been been around for a while, but it is one of the kind of last really big leaps that I feel like we've seen from a radar level space. But no, talking about the history, so I was at one of our factories over in Sweden where they do a lot of the design for our radar devices. And they have one of the first generation radars in one of their labs over there. And they have it in this big case, and the case is like numerous feet tall, wide, and
it's a refrigerator, basically.
Yeah,
right?
It's like a couple dorm fridge size kind of. Yeah, and it's crazy to see that that's what the first radar generation was, and now, 50 years later, Emerson is on their 6th generation of radar. So we've gone from these, really large, power-hungry radar devices to 2-wire, low power, low voltage, low startup power consumption needed, and we're probably getting way better measurements out of those devices than what we used to do with a big machine like that. So it was really eye-opening because I've seen pictures of those devices in a lot of the marketing literature that we've created. And of course, the thumbnail is really small. Yeah. So it's easy to think that that's just a small device like I'm used to seeing. But yeah, it was really eye-opening seeing how large that first device was.
I couldn't imagine trying to mount that on some of the... Because now, I'm thinking of the 1408 in particular, is like the size of an iPhone.
Right.
You can just throw it in a backpack.
Right. Yeah, you need a pretty large mounting bracket to get one of those over.
Yeah, the B4 bracket for pressure trans. You need a few of those, right?
Just a couple.
Yeah. It's funny, speaking of those B4 brackets, I always get a kick out of them because some of like part of a standard when we quote customers pressure transmitters, we always quote them a bracket.
Yeah.
Because you never know where you're going to need this bracket.
Right.
And a lot of times customers don't use the bracket. They already have one in place, or they're installing it integral to a pipe or something like that. So I went to one customer in particular, and they kind of asked, they said, why do you send us these brackets every single time, right? And I said, well, it's just a standard. It makes it really flexible for installation, right? Yeah. And they said, well, no, don't stop sending them. And then they brought me to their instrument shop, and all of their bookshelves were made out of our B4L brackets. And it was like, they're like, yeah, we got way more books that we have to hang. We need a couple dozen of these brackets, right? So they're slowly building this library in their instrument shop for not just books, like everything else too. And they're strong amazing brackets. So yeah,
I love it.
I thought that was kind of a funny unintended use for some of these things. Yeah,
that's very good. Because it's March Madness, so you use the term B4 because it's our option code, right, for the bracket.
Yeah.
In case anybody doesn't know that.
Thank you.
For a couple of years ago, when we did a March Madness bracket at work for NCAA men's basketball in the U.S., my bracket name was B4 bracket.
Oh, that's great.
I thought it was hilarious. I don't think I got as much love for it in the office as I deserved, but I thought it was hilarious.
I love that. I feel like I might have mentioned this on the show before, but I always get a kick out of the extreme cold options. And particularly for pressure.
Yes.
Burr 4 or Burr 5.
Yes. BR. Well, I think one of the original ones was BRR. Burr,
oh, just
like
Burr.
real Burr. Yeah. And then, yeah, actually, I think our flaming gas portfolio is. I just had this conversation. Our flaming gas portfolio is coming out with a cold temp option, and I asked the product manager if it's going to be BR or BRR, and he's like, "Oh, I don't know." And I'm like, I've always got a kick out of that.
That's a must.
Whatever product manager came up with that, kudos.
Smart.
It's so good.
Smart on them. So did you always want to become a radar master? I've been waiting to ask that one.
I saw that on the list.
Yeah.
I hope you're proud of it. Yeah. Well, no, I've always wanted to be a radar master plus.
Oh, good. Even better, right?
Yeah. When little kids were playing with toy trucks and race cars, I was playing with radar transmitters back in the day.
Filling up the sand in the box, and it was like, oh, we can fit more.
Kids were playing with trucks. I was monitoring the level of the sand in the back of their Tonka trucks. It's been a fun evolution kind of through the Emerson portfolio, and I've always been aware of our level products.
Yeah.
But I kind of grew up in our pressure organization, and I've done a lot of work in pressure. But actually, when I was in an industry space, when I worked in the food and beverage space a little bit more, I kind of covered all products that played into the industry for food and bev. So I did have to kind of self-learn level back then. And that was really probably my first foray into level products and kind of understanding what they do and where they're used and how our customers are using them. So, and then when an opportunity came up to manage the level portfolio, I kind of took it and wanted the next step in my career to learn more things. And there's so many different products across Emerson. So it's always fun to be a product manager, but maybe change products every once in a while. So you can do the same thing, but for a different technology. Yeah,
totally. Yeah, it's funny. I was kind of thinking about this too, right? Because, the former level specialist, and you might not think about that as a kid, that's what you want to do. But I have to say, I really enjoyed doing level. I feel like it was a ton of fun. I mean, there's a lot of climbing the stairs, a lot of cold tanks that you're outside, a few broken laptops. But it was really interesting. And I think, when you're in inside sales and you're working with customers and you're trying to solve problems, you're in an office, right? And you're not in those environments. And so when you get out into the field, especially with a tank, right? Like you're typically outside, or maybe you're inside, but when you get up to those tanks, I don't know, it really kind of puts you in your place and gives you perspective of, this is what our customers are like, this is the environment that they work in. And so if you're suggesting something, then they have to go up to the top of this tank every time to, get you some data or, to adjust the instrument, right? You're asking a lot of them. And so I don't know, the levels, when I was my foray into level, it really gave me a lot of perspective. And, I always found it to be really interesting just because the technology is so cool.
Yeah.
And there's many aspects to it. There's a safety aspect, there's a control aspect, and then there's also, inventory management aspects. So depending on, the challenge that your customer is trying to solve, you kind of have different approaches. So it's always different. It's always new.
Right. Yeah, absolutely. Your comment about always having to get up on a tank, hopefully we can alleviate from having to do that as often in the future, right? With the advent of Bluetooth and being able to get that data from at grade, and you don't have to get up on a ladder. So hopefully some of the Bluetooth technologies that are being released are helping keep people safe and off of tanks, only having to go up there when they really need to go up there.
Yeah, just to install it, basically.
Right.
Yeah. Maybe talk a little bit about some of the Bluetooth advancements, because I think since I had Rich on, that's probably been one of the biggest advancements within the level portfolio for Emerson.
Sure. Yeah. So we have Bluetooth on 2 of our radar level products, as well as one of our pressure products and our Coriolis products too. So we're starting to add this kind of across the portfolio. It's really nice because it's the same app for all of the products, whether it's a pressure product or a level product. And pretty much everything that you can do over a Trex or over a wired HART modem from a setup configuration troubleshooting standpoint, you can do over Bluetooth. So it's really slick. It's If you're used to hooking up to a device with a heart modem and waiting for the echo curves to load, you know that it takes a little bit to do that, and it's a lot faster over Bluetooth. So it is a little bit better experience. I love using the AMS device configurator on the PC app, the Bluetooth version there, and that's kind of what I've been leaning into a little bit more with when we release that feature. So that's a really, really great way to interface with the transmitters.
I have to say it's pretty handy to just pull up the phone or a tablet and connect. I don't think I've actually loaded any echo plots, so I didn't realize that it was faster via Bluetooth versus the heart modem. So that's amazing to hear.
Yeah, so we ran those labs yesterday, and we had some of the lab stations were hardwired, some were going over Bluetooth, and yeah, it's a definite.
You can see the difference.
You can definitely tell the difference on the refresh rate on the echo curves. So that's super nice.
Yeah, that is pretty handy.
Yeah.
And then you can maybe be in the warm and in the safety, especially in Canada or Minnesota, right? Northern states there to configure the instruments or check them out.
Absolutely.
Wow, that is pretty exciting.
Yeah.
And so, I know this probably isn't your expertise, but I think a common question that our customers have around Bluetooth is around security, right? And safety features. I think there's a lot of concern. Is their concern real? Maybe can you talk a little bit about what you're dealing with customers and how you kind of handle that with them, and are they okay with it?
Yeah. So you're right. I'm not an expert in this, but what I hear, I will share what I do know about it. So, all of our, actually I'll take a step back. So, Emerson invented wireless heart, and there is a ton of cybersecurity concerns bringing wireless networks into into different facilities. And there's a ton of work done on kind of the infrastructure and making sure that it was secure and that people can hack into those types of networks. Yeah. And the team that worked on a lot of the cybersecurity for our wireless heart division has been working a lot on the cybersecurity for the Bluetooth as well. So, a lot of things where everything's password protected when you log into a device. There's numerous different, you can log in as an admin or you can log in as a facilitator, and you can do different access rights depending on which profile you're logged into.
Oh yeah.
Like I said, everything's password protected. You can change the passwords. We don't keep the passwords, so that's another really big thing. So I know folks are probably concerned about Emerson having their information. So we provide the security codes or the passcodes on the device when we send it out.
And it's not just password or admin. They're complicated passwords.
Yes, they're very complicated. It makes running labs really difficult because they're very randomized. They're really great passwords. But yes, you can change them so that only you or your plant manager knows how to get into the admin side of a device. And so they feel very secure. When we kind of talked about some of that password management and the different profiles with different levels of access, we've had really good feedback from customers at some of the trade shows and customer sites that I've been to talking about it. And a lot of customers have felt like we were doing the right approach and locking it down the correct ways.
Totally. Yeah. And so, correct me if I'm wrong. So where you get this password is either the tag attached to the instrument.
Yep.
There's a sticker on the LCD display.
Correct.
And there's one more spot?
Yeah. So some of our devices also have it in the terminal block.
Okay.
Or on the terminal block or in the terminal housing as well. So I think the pressure and the Coriolis meters have them on the terminal block side. The 3408 is a single compartment housing.
Yes.
So the LCD is in the same terminal as the terminal block. So we don't have that extra sticker. But yes, we put it in numerous places, and if that little tag that's on the side of the transmitter were to get ripped off accidentally or something, which for security reasons you probably should be removing it after you install the transmitter anyways.
Yes.
But yes, there are numerous different places that we provide it to you.
Yeah, because that's always a common question. What if I lose this password? So it's in multiple spots. Now, let's say that LCD display, someone comes along and etches out the password. You can just replace the display. That's where the Bluetooth lives, right? In the display, not necessarily in the electronics beneath it.
Yeah, absolutely. So we do require an LCD if you do order Bluetooth. And really the functional reason of that is when you order an LCD, you get the glass cover on the meter cover. And if you didn't order that, you would just have a full aluminum meter cover, which will block the Bluetooth from being able to get out. So we do have the Bluetooth integrated into the LCD chip. And yeah, if you also have a device out there that does not have Bluetooth, you could just buy a Bluetooth LCD and pop it onto your existing transmitter as well.
I was going to say, yeah, like retrofit, I think is a huge upgrade. So especially if you have existing instrumentation, or if let's say thanks for muting me, Josh.
I forgot which button is mine.
It's okay. So retrofits I think is great. Or if right now, you're not willing to commit to Bluetooth. Maybe you have some concerns. Maybe you've got to pass through IT first. So you've got to go through some things, but you need the instrument now. You can always buy it without the Bluetooth display and then upgrade it at a later point. So I think there's many great reasons for that. So you don't have to just decide right now. It's something that, hey, it's coming across our entire portfolio. And so you don't have to make that decision now, but it's going to be something that is more readily available. And I personally love it. Just, yesterday we hosted some hands-on training internally here, and it just makes things so much easier to you don't need to get the USB heart modems out. You don't have to worry about, software. Someone can just get an app on their phone really quickly or tablet or whatever, right? And then we briefly touched on it a little bit, but the Radar Master Plus app within AMS Device Configurator, that was the first time I had experienced this, but if anybody's familiar with this software, when you open it up, now it actually gives you an option. It says, do you want to connect with Bluetooth or do you want to click connect wired? And the Bluetooth option is like super easy and seamless. I don't know why. I was just thinking, maybe this is going to be a little bit more cumbersome, like connecting maybe via Ethernet or something like that, but it was super easy.
Yeah, it's very much like connecting to a Bluetooth speaker or something that we're probably done on our phones, where you open up the Bluetooth and you can see all the available devices. That's how it works on AMS Device Configurator. And I actually found a bunch of people going into the Bluetooth settings on their PCs yesterday when we were trying to connect. And it's like, oh, no, you don't need to do that. It's all built into AMS Device Configurator. Yeah, so you log in and then you can see all your available devices, click on them, log in, and you're good to go.
And this is something that I also realize is an unintended benefit. Maybe it's intended. So I'm also used to connecting with, say, the 5700, which is a Coriolis transmitter that has Wi-Fi. So you can connect and talk via Wi-Fi. And so it's very similar, to the user. You don't really notice the difference. You just connect via Wi-Fi versus connecting Bluetooth. It's same data transfer, just wirelessly, right?
Right.
But the one thing is when you connect to an instrument via Wi-Fi, you can't be on the internet. And so I don't know if any of our customers would really care about that, but maybe they would, depending on the security protocols on their PC. So if you're ever trying to demo something or show something, quite often we host training via Teams, so you can't connect to the instrument wirelessly and then show people, because then this laptop becomes disconnected from the internet. So I don't know. It might only be me who has this problem, or a very specific situation, but that's one of the benefits of Bluetooth.
Yeah. Well, this is giving me flashbacks of back when mom was on the phone and you had to tell her to get off the phone to use the internet. Back in the dial-up days. I don't know.
No, I was there.
I don't know if you're old enough for that.
To use your term, I had a brief foyer with that, or I don't even know if I'm using that one right, but I do remember that, the dial-up internet. I remember trying to fight my dad to take the computer so I could play. We had, I don't know if you had this in the States. Sure, maybe you didn't, but we actually got... maybe this was early 2000s. We would get video games in our cereal. So you didn't have it? Oh man, you missed out.
Oh my gosh, you guys grew up so posh here.
It was amazing. Anybody listening, who is millennial-ish, will probably remember this. So some of the games were terrible. They were Mr. Potato Head and Scrabble, just some different games, right? But then we got Roller Coaster Tycoon. Have you ever played this or heard of this?
I've heard of Roller Coaster Tycoon, yeah.
So you would just buy a box of Fruit Loops, and hopefully you get the Roller Coaster Tycoon game. And this was hours and hours of fun. And you didn't need internet for it, so that was kind of the...
Cheerios are just throwing Game Boys and cereal boxes?
Yeah. Or it was the CD. Yeah, it was just the CD.
Oh, the CD. So, okay, it was the actual game.
Yeah, it was. I know. For back then too, cereal was probably only $4 or something. So it was one heck of a deal. And I remember, all the games were what you'd expect for a cereal box. But then Roller Coaster Tycoon was, I still love that game. If I had it on this computer, I would definitely be playing it every single day. That's where I realized I want to be an engineer, I think.
Yeah,
that game.
I feel like I really missed out on that. Maybe we had that. I just didn't.
You didn't eat cereal growing up?
No. We could. No, we did eat cereal. It probably just didn't hit North Dakota, the farming communities in North Dakota. Maybe that's what it was.
They didn't think you had, computers, right?
Right.
That's funny. Yeah.
That was a heck of a tangent.
Yeah, no, that's okay though. It was a nice moment for me to remember back to,
Good.
to those things. Yeah, I appreciate it. We'll see if the audience does.
Hopefully we can take that out in post-production.
No, all good. Okay, so but continuing on the technology trend, so eventually after computers, we got radars. Yeah, I hope you appreciate that segue there, Josh.
This is great. You've really pulled it back in. I love it.
So something that I think is really important to understand is the differences between pulsed radar and FMCW radar. So we talked about some of the older technologies, and we had a brief pit stop, as I like to say, with pulsed radars, and they're still out there. They're still in service. They're still working. Other manufacturers also still produce these. Maybe you could spend a little bit of time explaining some of the technology behind that, maybe the benefits of one versus the other.
Sure. Yeah. So when we're talking pulsed versus FMCW, or frequency modulated continuous wave, we're usually talking non-contacting radar specifically, not just specific radar, or not just radar in general, but usually non-contacting radar. And so when we're looking at pulsed radar, what we've traditionally done is we'll say that we'll use the example of a 26 gigahertz transmitter. So you are sending, microwave technology, a 26 gigahertz signal down into the tank. You're getting reflection off of the process inside the tank, and it's coming back up to the transmitter. And then once you receive the signal, then you send the next one. So you're only sending one signal of the same frequency at a time. And what has, traditionally happened is you only have so much resolution that you could get out of that, because there's only so many pulses that you can send, because you have to wait to receive that signal. So when we look at FMCW, what FMCW has done is it's added more frequencies that we are sweeping. So instead of maybe say just a 26 gigahertz frequency, we're going to send a 24 gigahertz wave, a 25, a 26, a 27, and 28. I don't think those are the actual frequencies, but just for simplicity's sake. And so you're sending 5 different frequencies, and then based on the reflection that the device gets, it knows which frequency it got. So you can get a lot more data. So we're sending about 5 times the amount of sweeps into the tank, and we get a lot more resolution out of what is actually going on inside the tank. So if you do have a moving process or different types of things, if you just send one pulse down, and if the process has kind of peaked a little bit here, you're going to think that that's where the level is. But when you get FMCW, you're getting a lot more samples across the surface of what's going on inside your tank, and then you can kind of know exactly where that level is.
Gotcha.
Yeah.
And this is something that we started with, was FMCW.
Yes. So we were the first to bring out FMCW into our NCR technologies. And right now, all of our non-contacting radar transmitters across our entire Emerson portfolio feature FMCW technology. So whether it's a 26 gigahertz transmitter or an 80 gigahertz transmitter, which we have both options within our portfolio, they are all FMCW. So you're getting that much better resolution inside your tank, a much more reliable measurement, transmitter kind of overall package. It's been really good.
And the only reason we moved into pulse radar, I think, temporarily is just because of the power consumption, right? We weren't able to get FMCW into a 2-wire process level instrument, right?
Right. Yeah. So just over the years, as we kind of talked about in the beginning, you have these large radars, they're very power hungry. And over the years, just, they figured out the better chip technology, better signal processing, all this stuff. So the packages have gotten a lot smaller. Power consumption has gone down. And so radar does tend to be maybe a little more power hungry than some of our other measurement technologies like pressure and temperature. But we now have enough power budget available to do numerous sweeps and different frequencies.
So that's another thing that's, I think, important to understand. So, we use FMCW technology with our non-contacting radars, but something that's often talked about is frequency, like the actual frequency we operate at. And I feel like that's become a much bigger focus, maybe in recent years. Maybe could you talk a little bit about that? What does that really mean? If I have a tank, what do I care what frequency it operates at?
Sure. Yeah. It's been an interesting topic to kind of learn more about. And, you know, as we've kind of recently added our 80 gigahertz transmitters to our portfolio. So a lot of the really common frequencies that you'll see on the market are 26 gigahertz or 80 gigahertz. Some of the tank gauging products are a little bit lower frequency, maybe 10, 12 gigahertz. And I've even seen some really high frequencies above the 80, like 120 really? As well. Yeah, we've seen some of those on the market as well.
But sorry, you can't sell above 80 in North America? I thought there was some limit with the radio frequency waves. I could be wrong about that.
I don't know that. I don't know the answer to that.
Because and this is my understanding. I could totally be off. Maybe we both don't know, and we're educating. We're just spreading, fake news. Gosh. but my understanding was the reason 80 has come out recently. Like, why didn't we have 80 gigahertz, 10 years ago or 15 years ago? And it had to do with the limits for, what you could actually operate in a microwave in a free space.
Sure.
And that being raised. Mm-hmm. I could be wrong about that, but that was my understanding of why now 80 was allowed, because that's the max. And then maybe that'll get changed. I think it's similar reasons why, you can't use a cell phone on an airplane, right? There's interference with these different wavelengths.
Right. Yeah. I guess I don't know the history or the regulation piece behind that, but yeah, so, when we're talking 26 versus 80 and sizing it for a tank, what we have seen is that whether, most applications that are fairly straightforward, if you need a radar transmitter, 80 or 26 is probably going to work. What we have seen is sometimes the lower frequencies. So when I say lower, I mean maybe on the 26 gigahertz range. If you have a lot of foam, if you have maybe some dust or some buildup of going on in the vapor space inside your tank, getting that slightly lower frequency can help you see through some of the obstructions a little bit better. But we're seeing a lot of really, really great performance with the 80 gigahertz as well. And, 80 gigahertz does allow, it's a slightly narrower, the frequency allows for slightly smaller process connections. So our previous 26 gigahertz transmitters only went down to a 1.5 inch threaded connection. And now with the 80 gigahertz, we are able to go down to a 3/4 inch process connection. So we're just kind of, able to open up into slightly new applications. And if customers have a 3/4 inch or a 1 inch connection on the top of their tank, we haven't been able to get into, mount onto that previously. So 80 gigahertz has allowed for that. There are a couple applications where the frequency just doesn't work. I think it's ammonia is one of them for, say, 26 gigahertz, where there's just the, properties of the process itself where it just kind of like absorbs the 26 gigahertz. I don't know I forget if it's ammonia. I should definitely fact check that before I put that on a recorded podcast.
Unknown.
Yeah, but there are a couple processes, known processes that 26 gigahertz just won't work. So then you can use 80, but then there are some on the 80 gigahertz spectrum too, where if and they're pretty rare. It's not like water or something.
Yeah. You're not going to run into it every
There
day.
are things where, just the properties of the frequency and what's going on inside the process where it just doesn't reflect the microwave technology. So, but yeah, it's, we have a ton of specialists to work through if you do have a tank and you don't know which frequency to use. Like I said, we have seen that a lot of times, and in most applications, you can use either. And maybe if you have a different process connection, or if maybe you have some really turbulent or foamy processes, maybe we would drive one way or the other. But a lot of times both work.
And I think we've kind of built our products out like with that in mind. Like if you look at, the 𝗧𝗜𝗠𝗘 3408, which was released, I think a year ago now, basically.
Yeah, about a year ago. We're just kind of on the 1 year anniversary of that. Yeah.
Yeah. Oh, we should have had a cake. Cheesecake. So I think with that one, that's an 80 gigahertz radar, and that would be, that's maybe not a premium product, right? It's also not maybe an economy product. It's kind of that, I always like to say, the Goldilocks, middle spot there.
Sure.
And I think there's a reason that it's 80 gigahertz. It's because it's going to work in a wide range of applications. And I think a lot of people get pretty hung up about beam width, right? Everybody likes to do the math. They got the angles. They got, 72 feet. This beam is this many feet wide with this cone size. And I think people get a little bit too focused on that without realizing, one, it's probabilities, right? There's a certain probability that the microwave is going to be within that. But it's also it also, I don't think, is really the first thing to look at, right? Because the reality is you can mount our radars. I think this is true for the 3408, definitely the 5408, 8 inches off of a tank wall. So we don't care if it's a 10-foot tank or a 100-foot tank. Like, that beam is obviously going to intersect with that tank wall, and we can still handle that measurement, right? So it's not, it's more about your process. So if you're going to mount a radar above a beam or inlet, right? Those things matter way more than how big is this beam width. And I think customers maybe got a little bit scared into this, thinking like, oh no, like I got to stay away from low frequency because XYZ reason, or someone told me this, right?
Right. Yeah. So you touched on a lot of really great points, and just beam width in general, like you talked about. No matter how narrow a beam is, there's always going to be a wash. So you're kind of talking about like that 3 decibel core part of the beam. There's always going to be part of the beam that's on the outskirts of the core beam angle. And so you're going to get echoes. You're going to get interference going on inside the tank, no matter how narrow that beam is. So what we've really seen, and this is really built, I believe this on the 50 years of innovation that we've done in radar. It's really signal tracking and signal processing and tracking false echoes and tracking what's going on inside that tank. And, it's being able to deal with the echoes or, the different reflections that you may be getting inside the tank, and not as much on what the actual beam angle is. So, yeah.
No, I totally agree. I feel like that's something that's just education, right? Just to get people to that point. And then, speaking of education, I think another piece maybe more impactful for customers to focus on is the type of antennas to use. I feel like that's actually something that is much more important to be fixated on. Maybe you could talk about some of the different antenna offerings, how that impacts beam width, maybe one where you use one versus the other.
Sure. We have a handful, of cone, and so you're talking about the cones and specifically on them, right? Yeah. So, we have many different types. We've got our cone, extended cone. So if you're in a long nozzle and you want to, minimize interference or ringing that's going on inside the nozzle, you might do some sort of extended cones. We also have our parabolic antenna as well. It's a slightly wider, antenna. It really gives the most focused beam angle, and it gets the most energy kind of down into the tank and reflected back. It also has the largest kind of receiver to receive the signal back as well. So we see that on really low dielectric constants. Solid style applications is a really common place to use the parabolic antenna.
And sorry, that's the one that looks like the big satellite dish for those who don't know.
Yeah, it looks like a big bowl, essentially.
A big salad bowl.
Big salad bowl turned upside down. And, you can wear it on your head if you want. It's a nice hat. So that's one really specific kind of parabolic. It's larger process connections, and for really low dielectrics is kind of where we do tend to see that. The cones are used to a little bit more get focused, slightly more focused beam angles. Actually it's what we call our process seal antenna, and it's a Teflon, kind of all Teflon window on the bottom of the transmitter, and there isn't a traditional cone or antenna extruding from the bottom of the transmitter. And I know that looks a lot goofy a lot of times to folks because they're expecting some sort of cone on the bottom. But we, when you have that all Teflon window, when we're looking at like different chemical style applications and you're looking at material compatibility, if you can remove that, the metal, or if you need some sort of exotic materials to deal with compatibility, that Teflon window has done really, really well for us. And even from a condensation buildup and different things, it provides a really, really good drip point to get condensation off of it as well. So we are starting to see a lot more kind of movement into that process seal antenna that we offer, and removing kind of the traditional cone from the bottom of the transmitter. We still sell a ton of cones, so I don't want to make it seem like a majority of our sales are moving to that process seal antenna, but it is a newer thing that we're trying out. And well, it's not even that new, but a lot of our, like our sanitary 1408 has that really, and that helps a lot with the sanitary approvals. And our 3408 has that same kind of process seal antenna on the bottom of it as well. It doesn't have a traditional cone going into the tank.
That's the lens one?
Yeah. So we have the lens antenna, and we also have the process seal antenna. So the process seal antenna is all Teflon window. And then the lens antenna does have a little bit of metal, but it looks like a little half of a golf ball sticking out from the bottom of the transmitter. Yeah. So the lens and the process seal antenna look very similar, but the lens antenna is where we're getting our threaded connections, and then the process seal is the flanged connections.
Okay. I always wondered where to use one versus the other, but they're basically the same thing, just for different connections.
Yeah.
Oh, okay. That's pretty interesting. And I remember, it's kind of funny, the evolution of the radar. So I remember with the pulse radars, was it on the 5402 or 5401? But they had like the pointed. It was like a, I don't know if you ever worked with that one. So it was like it was like a PTFE, but instead of a bulb, and I think the reason they did this was for, dripping, but it was almost like a big spike coming off, like a big icicle or something like that. Did you ever see one of those?
I have seen one of those. Yeah.
It's just funny, the evolution of it, where that, you went from this point to now a nice rounded bulb that's, and I wonder if it's because people are used to cones. So they said, well, this kind of looks like a cone, right? So
yeah,
I'm sure there was some much more technology and thought behind it than that.
You should be on the product design team.
Yeah.
You sound like you got it down.
That was like the whole joke of Elon Musk making the rocket ship pointier. Did you ever hear that one? So there's a movie called The Dictator, and it's a pretty funny movie. And basically in it, he's developing some sort of missile or something, and he said he wanted it to be pointier of a tip on the missile, because pointier is scarier, right? Because it was like really rounded.
Sure.
Yeah. So apparently, as a joke, in one of the rockets that Elon Musk and SpaceX were designing, he jokingly said it needs to be pointier, and then they actually made it pointier just as an homage to this movie. And apparently all the physicists said it actually made the performance worse, but they did it just because it was funny.
It made it work. Amazing.
So anyways,
I love it. Aesthetic over design every day.
Totally. I mean, hey, you know what? You want something that looks good too, right?
Right.
So,
yeah. All of my engineering professors are just, super mad right now.
Totally.
Yeah.
Anyway, so there's been a lot of designs changes and some advancements and some improvements.
Yeah.
What I thought was kind of interesting yesterday was, especially with radar, you have to kind of see it to believe it. Mm-hmm. So there's a pretty simple lab or experiment that many of our customers can do if you have, a 5408 and a 3408. So those would be, 80 gigahertz or 26 gigahertz and an 80 gigahertz radar. Maybe you can describe the lab you did yesterday with the marshmallow, but it seemed to be pretty interesting to simulate, I think, the effects of foam, and you can see kind of the differences between the two radars. Yeah.
So we have, two transmitters sitting on their side shooting at a little reflector plate to kind of simulate level inside of a tank. It was, flipped on its side. And so in front of the reflector plate, we'll throw marshmallows to simulate our level. We actually had a couple people eat some of the marshmallows. I was like, you guys, we got to get through 4 labs. Don't eat the whole bag of marshmallows.
Those are from the dollar store. I hope they're edible.
I do too. All of our marshmallows at our factory are like super dried out because we used them for such a long time. So people don't eat our marshmallows.
Mine were fresh. Yeah. Right off the press.
Oh my goodness. It was a wild day yesterday. And, so we put that foam on there to simulate, put the marshmallows on there to simulate foam. And, you do see a drop in signal strength for sure. But we, both the 80 and the 26 gigahertz is able to see through the marshmallows and see the plate on the other side. We also have the team take a tennis ball, and our 5408 demos do have a cone antenna on the bottom of it. So we just have them pop the tennis ball into the antenna itself, and, can it see through the tennis ball itself? And it can. And it does, again, the amplitude or the echo drops from the surface, but we are able to see through it. And even on the 3408 as well, we didn't have an antenna, but I saw some folks just throwing the tennis ball in front of the transmitter itself, and we were able to see through that as well. So one thing that a lot of folks don't know is that radar can see through plastic materials, right? So if you mounted a transmitter over a polymer or some sort of plastic tank and you didn't have a tap on the top of it, you can just mount that over it and it'll see through the plastic and it'll measure your liquid inside. So we're able to see through lots of different types of obstructions and or plastic materials. And
fiberglass too is another one.
Yep, absolutely. So that's always a really, really fun application. We've even seen some folks take kind of plastic flanges and mount them on the top of a tank. So it's not actually tapped into the tank, but it's just a way to mount the transmitter. And then it also alleviates from maybe moisture or birds making nests underneath your transmitter or different types of things. So it kind of isolates the process connection from the outside ambient temperature, but you're not actually tapped into your tank. So we've seen some really cool applications like that.
Yeah, I was just going to say, because that's, I always advise to try to put it into the tank if you can, just for that reason, because a bird makes a nest, or, it's outdoors, water starts to pile up there maybe, and then all of a sudden now it reports status levels. So you can do it, but I mean, ideally, you put it in the tank, or at least you mount it so it's enclosed.
Right.
And that's, for everybody's knowledge, that's not just a rose mount Emerson thing. That's just technology. It's just microwave-based technology. It's just the physics of it, right? So.
Right, absolutely. And we have tons of applications where we're just shooting through the tank from the top, or even people have mobile tanks where they're filling them. They have a fill station, and they'll just have a radar on top of it, and then they'll be moving the tanks around. You don't have to mount the radar and unmount it when you're done filling, or different types of things. So a lot of once you know that that's an option, there's a lot of really cool ways that you can use that.
It's kind of give me an idea here. I wonder if we'll ever see a point where, typically tanks are designed for the process that is going through them, not for the level transmitter. But a challenge we often see are mixing blades. I wonder if it's possible to make plastic mixing blades. That might help with some of those measurements.
Oh, sure. Yeah, you might have a reliability issue if you have a really viscous process.
I think it depends on the product. Which, if you have a blade like that, especially scraping the wall, there's probably a good reason for it. So.
Sure, yeah. But one of the nice things is with our Radar Master software is when you do have a radar installed on a tank with mixers in it, you can see the echoes from that, and you can kind of map those out. So you can get the radar to just ignore those types of blades. So luckily, we have the technology to deal with the blades that are in the industry right now. We don't need to force customers to use polymer or plastic mixing blades.
Well, that's kind of why I brought that up, actually, because it's how it was always described to me, which is pretty interesting, is that, there's some smarts to the radars beyond just the technology, where, in the analytics of it, where it's going, okay, if I'm always seeing this echo at this certain height in this vessel, it's probably not the level, right? If that's not moving up and down vertically like an agitator blade, it's going to stay at that same, horizontal plane. I can just ignore that, right?
Yeah.
Pretty confidently.
Yeah, absolutely. So our signal processing and signal tracking is so great. And we've seen so many tough applications where we've really put that to the test. And I think, talking to some of our microwave engineers, I think our transmitters are tracking up to 10 echoes inside of a tank at any given time. And they're doing what you said, is they're tracking those other echoes going on inside the tank. So you can either just have an echo that's always happening at the same point inside of a tank. But also, if your level, you're tracking your level up here, and then new echoes are going or moving down inside the tank, it will continuously track those echoes, and it's not going to jump to those echoes, because it's like, okay, well, I've known my levels up here. I've been tracking these echoes. These are false echoes kind of moving down here. And we actually saw a really, really cool application with this. It was in a bioreactor. So it was actually a life sciences facility, and they were using the single-use bags mounted inside of a frame. And they had used a couple different types of technologies. And as the bags would empty, so this is where we're also making the measurement through the plastic bag, right? So we're doing level, measuring it through the plastic bag, completely sanitary. So we're mounted on the top of this frame, not touching the customer's process. And as the bags would empty, they would leave these little moisture pockets, and the bag would crinkle down. And we had seen some other technologies maybe get hung up on the moisture pockets and lock on a different level. But our 5408 with the 26 gigahertz rate frequency was able to kind of see through some of those smaller moisture pockets and track those false echoes as they were kind of being created as the bag would slowly empty or fill back up. And that was a really, really cool application that we just kind of tried out our radars on. And we were able to see through all of that. So that echo tracking is real. It's very powerful. And coupled that with our 26 gigahertz frequency, it was a really good solution.
Some of the things I don't think people realize is the startup sequence that a radar goes through. Like, you plug in a pressure transmitter, you give it power, and it's basically ready to go, telling you the pressure. But there's a whole cycle that a radar goes through. There's a lot of things that it considers before it gives you that output. And something that I found is actually really handy is giving it a search window. So this is a cool feature built in. I don't know if you ever run into this. So basically, some of the applications where this is handy is if you have fast changing levels. So maybe in solids, you might have a dump truck dump wood chips or something, not like or. Sorry, I had to mix
with
it
an
up.
E.
Yeah,
or with an E.
With an E. Yeah, rocks. There we go. Or. So what happens is some of these vessels, they might change by 5 feet, 10 feet at a time. And so, the radar, it'll lose the echo because that level doesn't exist anymore.
Right.
And if you have a really big vessel, 60, maybe it's not even a vessel, maybe it's just a bin, right? Like 60, 80 feet tall. And if it could change by 5 or 10 feet at a time, if you can say, hey, it will change by maybe, let's say, call it 20 feet at the most or 15 feet at the most at a time. Now it has a window after it loses that level to then go look for, as opposed to trying to look at all the echoes within the entire vessel and try to figure out which one it is. I found that it helps us lock on to the new level faster than maybe previous generations could. So
sure,
yeah, there's a lot of really cool things in the software, and I think the software in particular is something that you could spend every single day and still learn something new because the amount of features in there. And one thing I don't know enough about that I was hoping you could shed some light on is smart meter verification for radars, because I totally get it for Coriolis flow meters,
right?
But it seems like magic for radars.
Sure,
I need to know more, Josh.
Oh gosh. Well, let me put my magic wand away. No, so you're right. So smart meter verification is something that we've had in our flow portfolio for a while, and it's provided a ton of benefit to customers with being able to extend their calibration intervals, make sure that they're confident that that device is working the way it was when it left the factory. And, coming out of the pressure world, and, I did a lot of time with temperature, is, folks know how to calibrate a pressure transmitter.
Yep.
Folks know how to calibrate a temperature transmitter. And we always get asked, how do I calibrate my level transmitter? And the reality is that we're dealing with the speed of, microwave technology. We know the speed of light. We, that's how we're making our measurements inside of the tanks. As long as your radar chip is working correctly, there's no such thing as measurement drift in the level world. So if you have overpressure effects for a pressure transmitter or sensor drift, that just doesn't happen in a radar sensor. So we have now added smart meter verification to our level portfolio on the 3408, and it will be coming shortly for the 5408 as well. And it's really to give, customers more confidence that they know that the transmitter is working the way it was when it left the factory. So when you run the verification script, it does a bunch of diagnostic checks throughout the transmitter. And really priority number one is making sure that microchip is working correctly. So there's a ton of diagnostics around that. I keep hitting this microphone. There's a ton of diagnostics around that. And we're also checking the memory, the firmware within the device as well. We're tracking any configuration changes that are happening. So if someone went in and changed the reference height or maybe the alarm limits, when you run smart meter verification, you're going to get a report that says, here's the old value and here's the new value. So if you weren't expecting something to change, you have kind of a documented report on what did change. So that's pretty cool. When we run smart meter verification, you also get, are we detecting a valid level? We're not necessarily saying, is that accurate? Because we don't have a reference point from where the accuracy would be. But we are saying, is the transmitter outputting a correct level? And then the other thing is we're also making sure, are we actually getting radar out of the transmitter and receiving radar as well? So there's some analytics around that, making sure that we are actually sending and receiving radar. So a lot of different function blocks that are being checked and tested. And then we print that on a report for you. So it's a printable report. Smart meter verification can be manually initiated, or you can have it scheduled. So you can run it every day, every week, every month, whatever you want to do. We'll save up to 20 of the verifications in onboard memory. So say you did it every 30 days. once a year you could connect to a transmitter if it wasn't connected to a server or something, and pull those smart meter verification reports out. And
so it's basically identical to micromotions for Coriolis, but for level now.
Right, absolutely. So, and of course, the functions that we're checking, Coriolis is checking tube stiffness, they're checking frequency, they're looking at drive gain, I believe, for a lot of their stuff. And yeah, we are just checking different function blocks within our transmitter, just because the nature of the technology is different.
Okay, that makes way more sense to me. Thank you.
Yeah.
So, and this might be a separate feature now. I think it's actually a separate diagnostic feature, the Smart Echo Test. So how does that fit into things? That's not part of SMV?
It's not part of smart meter verification. No, it is a separate test. So it's really a partial proof test for customers to run. So what we do is, we have our physical echo inside of a tank, and we'll say we have a 100-inch tank and our level's at 30 inches inside the tank. And in a safety high situation, we would be at 90 inches inside this tank. So we know we never want more than 90 inches inside this tank. So what you can do is you can set up Smart Echo Test to simulate an echo at 90 inches inside the tank. And what the transmitter actually does is it creates a false echo and it inputs it into the measurement electronics. The measurement electronics actually process that echo, convert it to the output circuitry, and then send the proper 4 to 20 milliamp signal to your control system. So I like to equate it a little bit to a loop test. So a lot of folks will run a loop test to make sure that you can get through the 4 to 20 milliamp analog range on a device. But we're not just driving the output of the transmitter to 20 milliamps per se. We're actually having the electronics process an echo at a certain point inside the tank and then send that output. So we're checking the output electronics, checking the control system, as well as checking the measurement electronics too.
I feel like I probably need an hour conversation with the microwave engineer to understand that part of it. The simulation of the echo, like actually making another echo so that it's not just we're just driving it to 20 milliamps. Right. Like, do you know how that works, or is that's still magic?
That's the magic wand. That's the magic wand. I don't know how they're generating it at the specific point. I don't know all the details on that.
So
but
crazy.
One thing that I have noticed is when you're running the Smart Echo level test, it will say, okay, here's where you set it, and here's where we wanted it at 90 inches, and then here's where the output actually is. And what you will see is the actual output of the transmitter will vary just slightly because we're still dealing with the accuracy of the electronics, and it is actually processing that echo. So I know a lot of times when I've run that simulation for folks say, well, why are we jumping from 90 to maybe 90.05 inches? And, it's all within our accuracy specifications, but that's a really, really good visual of we're not just driving the analog output to a specific value. We're actually processing an echo and having the electronics drive that output.
Wow.
Yeah.
I feel like it's one of these things that just requires a lot of knowledge to understand the physics of some of that stuff.
Right.
Whether it matters or not, I don't know. It's just these general curiosities.
That's that engineering in you. You just want to know
like
how everything works.
But how?
Yeah, I know.
Wow. That is really cool, though.
Yeah.
So a lot of great things have come out recently.
Yeah.
Before you go, maybe there's anything you can share with us about future things like that you can say in the the confidence of just you, me, this room, and all of our podcast audience.
And all 6 of your viewers.
16.
16. Oh, your metrics have went up.
Yeah.
I don't have a ton of things to share necessarily.
Or what are customers asking you for? What are you hearing a lot of? That could also be it too.
I think just in general in the industry, it's always usability, right? And how are we getting the data out of our devices and making it usable? And I really like our Radar Master software, and we're working to get everything on the same software platform. So that's a kind of a big initiative for us right now. Some of the new stuff we're working on is maybe some sort of mobile, being able to monitor level on mobile totes. So if you have any, totes that are going out to different chemical sites or different oil fields or whatever that may be, anything that's moving around, we're kind of playing around with some technology to track those from a GPS standpoint and as well as a level standpoint.
Oh, very cool.
And again, I'm going to go back to kind of usability as well. And, how are we getting the data out? Is it usable? What other variables are customers specifically looking for that we can get out of the device as we get, I think, one of the things that we've seen was Ethernet, right?
That's what I was just going to say.
Yeah.
APL, how does that come into the mix?
Ethernet APL has been a big discussion internally, and we are working on some solutions for that. And I think one of the things with when we have that amount of bandwidth available to us and that amount of data to traffic, what other variables can we be pulling out of a device? Because a lot of times, like a pressure or temperature sensor, they're very simple, and you have a handful of diagnostics or that you're getting your primary variable. And now I'm sure our design teams are looking at, we got more info available to us. What is valuable to the customer and getting that out. So I'm really excited to see, how the industry moves when Ethernet becomes more available in a 2-wire package, not just 4-wire. And what we're going to be able to do with that extra data. So sorry, I don't have a ton of great,
that's fine. That's
forward-looking things. I have, I've seen some things, but I'm not going to share them right now.
Fair. Well, and in all fairness, anybody who's been closely following Rosemount level portfolio knows this past year there's been a lot of advancements, product releases. We got the 1208, 3408, 3490, various features within the 5408. There's probably a bunch of things that I'm still forgetting on here too, but and that even isn't it, all of it. There's so much within each one of those. Yeah,
you're right. Our numerous transmitters being added within any portfolio is a really, really big deal, and Level's had a bunch of those releases recently. We also just recently extended our measuring range on the 5408 up to about 490 feet.
Crazy.
Which is crazy. Was that 150 meters, 150 meters?
I know it in feet.
Okay.
Yeah, I can do both.
I was trying to be sensitive. One of the other things that is a recent advancement in our portfolio is we added a 10-year warranty onto the Rosemount 5408. And I've been doing some research, and I was asking around and trying to see what other products in the Rosemount or Micromotion portfolios have a 10-year warranty or more.
Yeah.
And the only product, I don't think Flow has any. And the Rosemount 3051S has a 10-year or a 15-year warranty, depending on what options you select. And the 5408 has now released a 10-year warranty. And if there's any product in the world that I want to be seen on, or be a part of the conversation with, it's the Rosemount 3051S.
Totally.
So getting that 10-year warranty has been really exciting. That's on awesome. The 5408, and I don't think we talk about it enough. No. And our design teams are so confident in that product and that it's going to last you so many years. Wow. And a 10-year warranty is just kind of wild. So set it and forget it.
Literally, right? and so I think people take that for granted when they hear something like that, right?
Right.
Like especially because for pressure, it's just kind of that's the 3051S. But for something like the 5408, like as far as I know, we've never had a warranty like that for level products.
Right. Yeah. And again, it's an advancement for even just the whole portfolio in general. A lot of our products offer 3 or 5 year warranties, which is really great. But getting up to that 10-year warranty, it's really putting your money where your mouth is and guaranteeing that product's going to work the way that we think it's supposed to for 10 years.
Wow.
That's longer than you've worked here at Lakeside.
I was going to say almost as long as I've been alive. Yeah.
If you had bought this on day one at Lakeside, you would still have about 3 years left on that warranty. So
I was going to say, would it have arrived by now? Yeah.
We don't have any supply chain issues on our core products for Level now. How dare you bring that up?
Yeah. I had to throw a shot back.
That's okay. Put me on blast.
Yeah. Well, Josh, thank you so much for coming to the show today.
Yeah.
You were a great guest. I really learned a lot. If anybody else wants to learn more about our radar products or anything else process level related, switches, guided wave radars, where can they reach out? Where can they go to learn more?
Yeah, absolutely. So, first they can obviously reach out to your team here at Lakeside. You are boots on the ground kind of representatives here. Canada or in this territory in Canada here. And feel free to reach out to me on LinkedIn. I love connecting with folks and answering questions over LinkedIn. We've got tons of specialists at our factory. So if you have any questions when you're trying to wire up a transmitter or troubleshoot something, we have our 1-800 numbers on the Emerson website if you need any technical support that way. But yeah, plenty of ways to reach out to us. But yeah, find me on LinkedIn. I love connecting.
Okay, awesome.
Awesome.
Well, thank you, Josh.
Thank you so much for having me. I appreciate it.
We'll definitely get you back when you're back in Toronto next.
I love it. I will definitely stop by the studio.
Oh, fantastic.
All right.
All right. Thanks, everybody.